Once, the word computer referred to a massive machine, a complex contraption that slowly made its way onto our desks. Then it shrank to fit in the palm of our hands. But technology never stops evolving. Now, scientists are developing a remarkable device that could completely redefine the speed, power, and concept of computing. Its name is quantum computer. A quantum computer could be millions of times more powerful than our traditional classical computers. By harnessing the strange laws of quantum mechanics, these machines can perform thousands of calculations simultaneously, solving problems that were once considered impossible for normal computers. This isn't just a possibility of the distant future. The journey of quantum computers has already begun inside laboratories. In this video, we'll explore what quantum computers are and how these powerful machines actually work. If you're new to Brain Boost, please subscribe and hit the bell icon so you never miss an update. Back in the early 20th century, when scientists began studying atomic particles and their behaviors, the foundations of quantum computing were laid. That era gave birth to a whole new branch of physics, quantum mechanics, which opened up new dimensions of understanding the universe. Between 1900 and 1930, great physicists like Max Planck, Albert Einstein, Niels Bohr, and Werner Heisenberg discovered that the subatomic world follows completely different rules. These rules would eventually become the basis of quantum computers. The first major contribution of quantum thinking to computer science came around 1980. In 1981, legendary physicist Richard Feynman said, "Nature isn't classical. And if you want to simulate nature, you'd better make it quantum mechanical." Meaning, nature itself behaves in a quantum way. So to understand nature properly, we need quantum machines. This idea triggered the conceptual development of quantum computing. In 1994, American mathematician Peter Shor developed an algorithm that showed how a quantum computer could break down extremely large numbers, something classical computers can't do efficiently. These large numbers are the basis of today's internet security. Shor demonstrated that if a quantum computer is built, all current cybersecurity could be rendered obsolete. Then in 1996, Lovegrover introduced a quantum algorithm that could search databases at an unprecedented speed. These theoretical advances ignited hope for practical applications of quantum computers in the future. The computers we use today are known as classical computers. They work using just two digits, 0 and 1, known as bits. But quantum computers go a step further. Their core unit is the qubit, which is similar to a bit but significantly more powerful. A qubit can exist as both 0 and 1 at the same time, a concept called superposition, allowing it to perform multiple calculations simultaneously. Moreover, a mysterious quantum phenomenon called entanglement allows one qubit to affect another, even if they're physically separated. This makes quantum computers much faster and capable of handling complex problems. This technology is powered by the strange yet fascinating world of quantum mechanics. Quantum particles behave in unpredictable ways. Scientists realize that if we can artificially control this behavior, we could build a new kind of computer capable of solving calculations that would normally take thousands of years in just minutes. Since the 2000s, tech giants like IBM, Google, and Microsoft have been investing heavily in quantum technology. In 2011, Canadian company D-Wave created the first commercial quantum-like computer, although it wasn't a fully functional quantum computer yet. Then in 2019, Google claimed to achieve quantum supremacy. Their quantum computer Sycamore solved a problem that no supercomputer on Earth could manage. Today, countries like China, the USA, and European nations are racing ahead in the quantum domain. Though quantum computers are still in experimental stages, scientists believe they could revolutionize everyday life within the next 10 to 20 years. If quantum computers become a reality, they could accelerate drug discovery, completing months-long research in mere hours. Right now, analyzing a protein or molecule's behavior costs millions of dollars and can take years. Quantum computers could simulate atomic behavior and create potential drugs much faster, revolutionizing treatments for cancer, Alzheimer's, or COVID-19. They could also give us ultra-accurate weather forecasts, warning of cyclones, earthquakes, or tsunamis far in advance. This requires analyzing billions of variables, something quantum computers could handle faster than real time. They can solve complex mathematical problems critical for banking and cybersecurity, especially in breaking large prime numbers, enhancing digital security to unprecedented levels. In space exploration, quantum computers could help us understand black holes, dark matter, and dark energy, even increasing our chances of finding life on new planets. Above all, quantum computers will supercharge AI and machine learning. While today's AI has limitations, quantum computing could enable AIs to perform reasoning and calculations we previously thought impossible. For example, using AI with quantum computers, we could predict future economic shifts long before they happen. In fact, Google's quantum computer Sycamore solved a problem in just 200 seconds, something that would have taken the world's best supercomputer 10,000 years. Quantum technology also enables quantum key distribution, QKD, a form of encryption, where any hacking attempt is automatically detected since observing quantum information changes it. So quantum computing isn't just a new kind of technology, it's a new dimension of knowledge. It has the potential to redesign our entire civilization. Scientists believe that whoever masters this technology first will lead the world in the future. When quantum computers merge with artificial intelligence, many existing global systems and assumptions will undergo a radical transformation, because AI is arguably the most impactful technology since the discovery of electricity. If you want to catch our future videos as soon as they're released, don't forget to subscribe to Brain Boost and hit the bell icon.